I'm Anil Kumar. Welcome to my series on vectors. In this video, we'll discuss about intersection of lines and planes. I'm sharing with you all the questions from previous test paper. Let me thank my students for sharing their question papers with me and performing so well. Now this is the test paper MCV4U which I've taken. We'll discuss all the questions in this test paper now. It is about an hour long. First, let us see the type of questions we have. Question number 1 is a multiple choice question. You can always pause, copy these questions, solve them, right? So these are the type of questions, multiple choice, question number 1, which continues, and we have some more. Question number 2 is true or false. You have to provide reasons for each statement. And then we have knowledge-based questions. We'll find direction vectors, we'll find intersection of systems where we'll consider 3 planes. We'll find intersection of 2 lines, we'll find different problems related to the same, and use all the methods which you have discussed while learning this chapter. We'll also calculate distance between point and a plane, point and a line. With that in mind, let's begin and solve this test paper. Question number 1, straightforward. Which of the following is not possible number of intersections between line and plane, right? So basically, if you have a plane, right, in that case, a line could actually go through the plane, right? So it could go through the plane, giving rise to 1. Line could be in the plane, giving rise to infinite numbers, or line could be parallel to the plane, giving rise to no. And of course, 2 is the answer which we are looking for. 1b. For what value of k do the equations have infinitely many solutions? We are given 2 different equations. Solution really means that one point which will satisfy both equations, right? So in this, what we could do is we can isolate y, substitute in the other one, right? So that's what we could do. So one equation is k plus 14y minus 50, and here we have x minus 7y. So let me write 7y as equal to x minus 25, correct? Since we are looking for 14y, 14y will be 2x minus 50, correct? So I'm going to substitute this 14y with 2x minus 50 to calculate the value of k. Straightforward, right? So we get k plus, instead of 14y, I'm writing this, which is 2x minus 50, right? Already we have 1 minus 50 here, equals to 0, right? So that means k will be equal to, taking these 2 minus 50s to the right side, gives us 100 minus 2x. Perfect. So we get a solution which is 100 minus 2x. 1c. What is the relationship between x plus 2y minus 5z equals to 3 and 7x minus 5y plus 2z equals to 1? Now these are 2 different planes in Cartesian form. So how are they related? So we have the equations which is x. If I multiply this by 2, the normals here are, let's write down the normals of these 2 planes, which is 1, 2 and minus 5, correct? So that is one normal. The other normal here is 7 minus 5 and 2, right? So that is the second normal. Now n1 and n2. As you can see, these normals are not parallel, and therefore these planes will intersect. And the intersection of these planes will be a line, right? So they will intersect along a line. That becomes our solution. Is that clear to you, right? So that is how we're going to answer this. The next one here is question number 1d. Which is the solution of the given system? So we are given 3 systems here, and we need to find which one is the solution. Now the best part is that, we are given the solution. substitute and check. So the strategy here is to substitute and check, correct? So that will ensure that what is the solution. Let's begin with 0. So if I write 0 here, I get the first one. Let's write 0 here. We get 0, and substituting -1 here gives me +4, and 1 there plus 2 is indeed 6. So it works, right? This part works. Similarly, if I substitute in the second equation, which is 2, and then we have -1, and then we have -3. So that gives me -4, so that also works here in the second one. And substituting 0, -1, 1 in the third one, what do we get? We get 0, minus becomes plus, and 1 gives us +10 equals to 15. So that really works. So A is the solution. E. What is the nature of intersection between the following planes? So we are given 3 different planes, and the options here are planes intersecting at a point, all planes intersect along a line, 2 coincident planes intersecting third in a line, all coincident planes. Now when we say coincident, that means the normals should be scalar multiples, right? So let's look into normals. So in the first one, n1 is equal to -1, 3, and -2, right? n2 is what? n2 is 3, 9, 6. 3, -9, right? And 6. And n3 is what? n3 is -4, 12, and -8, right? 12 and -8. So, well, what you see here is that they are scalar multiples, right? So if I do times 3, I get this one, right? Rather -3. So we get this one, and to get that one, it is times 4, correct? So they are all scalar multiples. That means they are all parallel planes at least, right? Now let's see if we have a common point on them, right? If I substitute 0, 0, 0, we get -1 here. Substituting zeros, we get 3 there, right? And substituting zeros, we get -4 there. So what we see from here, that all the planes are actually kind of, let's find a value of z, substituting these two as 0, right? So if I substitute x equals to 0, y equals to 0, then we get z equals to half in the first case, right? In the second case, if I substitute these as 0, we get what? We again get, in the second case, we get 6z equals to 3, and z equals to 3 over 6, which is again half. And in the third one, if I substitute zeros, we get -8z equals to -4, right? So z equals to half. Now what does that give you? Well, that clearly tells you that these are exactly same planes, right? So all planes are coincident, right? So that is what it is. What you could also do here, which is much faster, of course, is you could multiply the first equation as a whole by 3, which we did, right? So -3 becomes 3, and when you multiply by 4, it becomes -4, right? The first equation. So you see that they are all scalar multiples. They're exactly same planes, all coincident planes. Is that clear to you? Many different ways, but well, definitely the shortest is this. But when you multiply it, also multiply this term on the right hand side, so you exactly know whether they are coincident or not. Perfect. Okay, let's move on and take the other two of question number 1. Here we have, what is the distance between a point and the line with the given equation? And question number 1G is, what is the distance between the origin and the plane with the equation given to you? I'd like you to pause the video, calculate the answer, and then check with my solution. Question 1F. What is the distance between point 81 and the line with the given equation? Now the equation of the line is given in Cartesian form. So distance you can easily find by, it's always a distance is always equals to the absolute value, and it is square root of the direction vector. In this case will be -3 square plus 4 square And here, substitute 8 here. So we get minus 3 times 8 plus 4 times 1. Correct? So that is what you do. You just substitute these values and calculate your answer. So which is 24 minus 24 plus 4 divided by, that will be 5. Correct? Absolute value you have to take. Right? So you get what? You get 20 over 4. So we are taking absolute value, it is negative 20, but distance is always positive. So we get 4 as our answer. Okay. 9, we are finding distance from origin to the line, right? So in this particular case, you have to substitute origin means 0, 0, 0. So basically, it is again distance will be absolute value of, when you multiply by 0, all these things, right? Let me just write this. It could be some other point also, right? So in this case, it is origin and square root of all these terms, right? So we have 3 square plus 2 square plus 5 square, correct? So that is what you have to calculate. So we do get 7 on the top, okay? And denominator will be 9 plus 4 plus 25. You can use calculator to figure this out, square root, okay? But absolute value, correct? So which is 7 over square root of 38, right? So 29 plus 9, 38. So when you rationalize, you get this as your answer. So we get option D as your answer. Okay. The question here is, which best describes the nature of intersection of the following system? 2x minus y equals to 10, minus y plus z equals to 3, minus 4x plus 2z equals to 1. Do we have planes intersecting at a point? 2 coincident planes intersecting the third one. C is 2 parallel planes intersecting a third. And fourth is planes form triangular prism. Now let's look into the normals. So we could actually solve this also. So the first equation is 2x minus y equals to 10. So we could write this, the normal here as n1 equals to 2 minus 1, right? So 0. For n2, minus y z equals to 3, it is 0 minus 1, 1, and n3 is minus 4 plus 2 z equals to 1. So we get minus 4, y value 0, and then we have 2, right? So these are the three normals. Now if you look at these normals, they are not scalar multiples. So therefore, these two options are incorrect, right? So these two are wrong. So one of these options could be correct for us. Now we need to figure out whether it is a case of a triangular prism or it is a case of point of intersection, right? So in that case, one thing which separates them out is if you find scalar triple product, right? If you find scalar triple product, and if this scalar triple product is equal to 0, in that case we'll get triangular prism. But if it is not equal to 0, we get point of intersection. Okay, so that is kind of key. So it's basically scalar triple product. Actually, when you get 0, there could be a line of intersection also. So they could intersect in a line also, right? So those are the two conditions. Now that is one way you could do it. Now let me share one more thing with you. For triangular prism, if the question was changed and if you are just checking whether it is a triangular prism or not. So for triangular prism, we have one more condition which you could work out, and the condition is that if these are intersecting into lines separately, in that case we'll have n1 cross n2 equal to n2 cross n3 will equal to n1 cross n3. So what we'll notice here is if the direction is same, the cross product will give you the direction of the line, right? So that basically means they intersect in lines, right? So intersection is line. So same direction. Is that clear to you? So that is another way, and this way will tell you whether it is a triangular prism or not. But here, since we have a confusion, right, we could actually adopt any particular method. We could say scalar triple product and then figure out, or we could do cross product of all the three and then check, right? Either one of them. But I'm going to adopt the third method here, and basically we'll solve this using augmented matrix, right? So let's solve. And then there is no doubt about it. So we have these two equations as 2 minus 1 0, and this is 0 minus 1 1. Here we have minus 4 0 2, right? And this equation is equals to 10. The other one is 3. The third one is 1, correct? Now if I have to make this as 0, I have to multiply R2 by R1 by 2 and then add. Right, so if I do that, so I will do R1 times 2 and then I'll add this, right? So add R3. This will become 0, right? Okay, so let's do it. So once we do that, we get 2 minus 1 0, and this is 10. We already have a 0 here, so no need to worry. Multiplying by 2 gives us 0 here. 2 is minus 2, so we get a minus 2 here. And that remains at 0. This is 3. Multiplying this by 2 and then adding will give us 21 here, right? Okay. Now we need to make this as 0. So what should I do? To make this as 0, I have to multiply R2 by minus 2 and then add, right? So I do R2 times minus 2. This time we'll do R2 times minus 2 and then we'll add R3, correct? So what we get here is 2 minus 1 0. Here we have 10. Let's leave this as 1, and that is 0. Minus 2 makes it plus 2. When you add, you get 0. Minus 2 makes it minus 2, and you get 0 here also. Minus 2 makes it minus 6, and when you take away from 21, you get 15, correct? So you get a state here which says 0 equals to 15. Do you see that part? So that means the system is inconsistent. Correct? It is an inconsistent system, and so out of the given choices it becomes triangular prism. Both of them will intersect in a line, and we get triangular prism as our right choice. Is that clear to you? Perfect. Now I will like you to check these 2 points. What is the value of scalar triple product? Is it equal to 0? So you'll check that this is indeed equal to 0, and you could have done that. If you do n1 cross n2 and all this, even then you'll find it correct. So I'd like you to verify for the given example that everything works. So you could have adopted any particular method to figure out whether they are intersecting in a plane, they are intersecting or not intersecting, or whether they are intersecting into a triangular prism or at a point, right? Especially distinguishing between these two, I'll prefer this method to be adopted. Is that clear to you, right? Question number 2. It is a true or false question. You need to provide reasons for your solution. 2a is the distance of the line r equals to 1 2 minus 1 plus t times 0 1 1, where t belongs to real numbers, from the point P, which is minus 1 1 6, is 6 units. Now you can always use the distance formula, which is distance is always absolute value, right? So whatever is the direction which is given to you here, right? So it is direction cross product with P, let's call this point as Q, right? So cross product between P and Q over the magnitude of direction, right? So that is the distance formula. You can use this formula and verify whether it is 6 units or not. 2B, if two lines in R3 never intersect, they must be parallel and distinct. Well, in R3, if the lines are not intersecting, this statement is false definitely, since we could have skew lines, right? So skew lines will never intersect. They are in parallel planes, right? So that is additional case, right? So we are saying if two lines in R3 never intersect, they must be parallel. Well, they may not be parallel. So skew lines are not parallel, right? And therefore, this statement is false. 2C, a system of consistent equations has always one solution. Well, consistent equation can also have infinite solutions, right? So infinite solutions is also possible. Therefore, this statement is also false, correct? Now, let's try to figure out whether 2A was correct or not, right? So, we are given P, let's find what PQ is. So, PQ will be, this is the point, 1 minus 1 will give us 2, 2 minus 1 will give us 1, minus 1 minus 6 will give us minus 7. So, that is PQ. So, now let's find what is magnitude of M. Magnitude of M is, that is the direction, right? So magnitude M is 0 square plus 1 square plus 1 square, which is equal to square root of 2. And now we'll find the cross product between PQ and M, right? It could be written either way since we are checking the absolute value. Okay, so basically we have PQ is, let's figure this out. So let me write down 1 minus 7 2 1. M is 0 1 1, so we write 1 1 0 1, right? So when you do the cross product, it's kind of like this, right? You add these terms, right, and subtract the other ones. So what we get here is 1 times 1 as 1, and then minus this. So minus this is plus 7, right? Minus 7. That is the I component. J component 0 minus 2, right? And this is 2, right? 2. So basically what we get here is 8 minus 2 and 2, right? So that is the cross product. Now we need to find the magnitude, right? So magnitude of this word, magnitude will be equal to square root of, let's figure this out, 8 square plus 4, I mean we can write like this, is it okay? So 64 plus 4, 68 plus 72 we get, right? 72. So that becomes the absolute value 72, which is PQ cross M, right? Now let me write down the solution in between, which is distance is equal to M cross PQ, which we figured out as square root of 72, sorry. So we have square root of 72 over, we have square root of 2 here, which is square root of 36, which is indeed 6. So this statement is true. Is that clear to you? So that is how you're going to do it. So I just did all the calculations here to show you the result. So I hope you find it perfectly fine. Let's move to our false. Question number 2D. These planes will always intersect in a point no matter what A, B and C are. So we are given 3 different planes. How will you prove this? Now that is very interesting. We just learned in previous example that if I do scalar triple product, right, of 3 normals, and if it is not equal to 0, that means intersection at a point. Is that clear to you? So this is a very important condition, and of course we'll do the cross product first, right? Now in our case, n1 is equal to 111, n2 is 123, and n3 is 149. So let's do the scalar triple product and verify the result. Is that clear? So we have 1, 1, 1, 1, 2, 3, 1, 4, 9. So that gives you 1 times 2 times 9 is 18 minus 12 minus 1 time 9 minus 3 plus 1 time 4 minus 2. So that is equals to 18 minus 12 is 6. This is 6 minus 6, right? And this is 4 minus 2, which is equal to plus 2, right? So this is equal to 2. Since scalar triple product, very important condition actually, is not equal to 0, it is equal to 2, right? Intersection will be at a point. Is that clear? Now this is a very important criteria which is missed many times by the students, and I hope that is going to help you a lot in solving any test paper based on lines and planes and their intersections. So we'll end the part 1 at this stage, and in part 2 we'll take more descriptive, knowledge based and thinking questions. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.